Hello, I'm Ryan Madarak, chair of the Physics and Astronomy Department at Benedictine College in Atchison, Kansas, coming to you from Daglin Observatory, our campus observatory. We have here an image of the Dumbbell Nebula taken right here at our observatory. It, of course, is a planetary nebula, one of the most photogenic types of objects in the sky. But how does an object like this happen? When we look at that, we can clearly see the white dwarf in the center. We can see the envelope of gas that was ejected. What's the story? The dying phase of a sun-like star is the post-asymptotic giant branch. And those stars go through variable phases, specifically RV Tauri variables, which are the well-known Hamel's hump stars. If you can see its light curve there from the AAVSO, with both primary and secondary minimums. But then you have this other related class of stars called SRDs, which show a lower amplitude, more sawtoothy light curve. So why do we care about these? They're pulsating yellow supergiants. They're long period variables, periods of months. What we're really interested in is the relationship between these types of stars. What's the story of their evolution? So, like I said, these are the remnants of sun-like stars. They pass through the variable star instability strip on their death march to the white dwarf graveyard. And this is a very brief phase, 250 years. So we catch this in what for these stars is just a blink of an eye after a 10 billion year lifetime. So one of our astronomers who was here years ago, Scott Baird, came up with a model to describe RV Tauri stars. And the basic idea is that they have two periods. So the atmosphere of the star is pulsating in the fundamental, and the interior pulsates in the first overtone, which is to say the interior is pulsating at twice the frequency. And so that means that twice per cycle, those layers crash into each other, and there are shocks, and those shocks can throw material off, and that's where you can perhaps start to get your planetary nebula. That's why you have this camel's hump alternating light curve. So the question is then, what about these SRD variables? They're basically the same kind of star. They show pulsational behavior that's similar to, but not the same as RV Tauri's. What's the relationship between those two? Can they evolve between each other? Are they the same type of star? Are they completely different stars? Can we understand them with the same model that we apply to RV Tauri's? But the big question, the reason that you should care about this is we're trying to answer the question of how a star like the sun dies, how those gorgeous planetary nebulas that we like to take pictures of, how did those happen? And one of the things I love about this area of research is this is a place where the amateur community can and has made a big impact contributing light curve data and spectra. It's an exciting area with many unanswered questions. So there you go. This is a place where the amateur community can really make some big contributions because these long period variables, nobody at a big professional observatory with a meter class or more telescope is going to give you months and months and months of nights so you can get even a single cycle of one of these stars. So small college observatories like ours and the amateurs are the ones that can do this work.